Okay, sorry again, I know I'm fast. Alright, so we go do the pipeline again. Here, click on geometry solid, click on cylinder, and the radius we say 0.6, so it'll be 600 millimeters, and the total length is from -6 meter to 6 meter, and apply, and we have this one. Now we click here, element and mesh, click auto measure, and from here click on the surface that you want to make the mesh. Okay, we already clicked this one. This side and the other side we don't want it, so you don't highlight this one. But if say by accident you click on this one, you want to unclick, you use the right mouse button to unselect the part or the surface. Okay, here you have many options, but for the basic one we go to the size, compute. This one, the software, again it will calculate how big the suitable size, and then click on mesh, and now you have this one, and click on accept. So now you have, okay, so I hope everyone is okay now. Okay, or something different? You can see. You click on accept already. Did you click accept mesh? Accept. Okay, sometimes depends on your software, depends on your LSP post. Sometimes you cannot see the mesh. Okay, but if you cannot see, you click on this one. See this one. If you cannot see, you try to click on this one. Okay. All right. Okay. Why this happens? Because Windows have 32 and 64, right? Sometimes it's not compatible. All right, because the version I give you, I think 64, because it is with the manager, DYNA manager. Sometimes not compatible, and it is not the latest. You can see is 4.3, and it's August 2016. You can download the new one, latest one, for free actually, and it's from this website, lstc.com/download. Okay, if you have internet you can download, but if you do not have, it's okay. Now this is the pre-post. The pre-post, you don't need any crack. Yeah. Okay, everyone doing good? Okay. Now you try to click on F2. Click on F2, you have this one, assembly and select part. Yeah, F2. Okay, what you see now is like overlapping between the mesh and the geometry in the pipe. The green one and maybe the red one. So right now you want to hide the green one. You go to assembly, you open here. Now you see you have two, the shell and the solid. The geometry is the green one, we don't want it because we cannot do any analysis on it. So right click and blank. Now you can see the mesh. Okay, again I repeat. You click F2, you have this small window and you have three tabs: part, G part, and assembly. You click on the assembly, you see you have two things, one L shell and solid. Alright, This one you can see it has a small mesh, meaning this is the mesh, the element that you want. So keep it as it is. Here the solid, you don't want to see it because it might be confusing for you. So you right click and try blank geometry. Okay, so everyone can see the mesh now, huh? Okay, problem thing. Okay, wait. Yeah. So yeah, I will just continue with this one. Yeah, okay. It's just a viewing problem. It's not a big matter. So since most of you can see like this, I will continue here. Okay. All right. So now we are done doing the pipeline, the section of the pipeline. Now we are trying to do the piece of rock. All right. Let's say we have, you see on the whiteboard here, we have a big piece of rock is maybe falling on the pipeline. So we go to here. Sorry again. Here, model and part. Okay. Sorry. We go here, element and mesh. And we go shape measure. The first one. Yeah. And from there, you have many options. You can click on sphere solid. Okay. Now we can choose the radius. We can choose the size of the element. Okay. Because we just simplify, we say the rock looks like a ball. Okay, for simplification. So let's say the radius is half a meter, and the density try to put 10. Okay, now if you click here, you will see some problem. See, the rock is actually inside, so you reject. You need to shift the center of the rock. So let's say we put it in X direction. You see this is X. We want our rock to be here. So let's say we try to put 1 meter. We create Now you see it is still overlapping. So let's say 1.5 meters. Reject and create again. So now it's quite okay. And after you do create, you click on accept. Just copy the parameters, radius 500, density 10, and the position of the center. X is 1500, Y and Z are 0. The rest, just don't play with them. And then click on accept. Okay, everybody getting something like this? Okay, so right now we proceed. Okay, click on F2 again. And now you see under the tab part, you have shell and you have solid. Okay, you have shell and you have solid. If you tick on shell, you have the pipeline, the tube. If you click on solid, you have the rock. Okay, so now I want to explain a few things. This one is hollow inside, right? And it has a thickness. So let's say we assume the thickness to be, let's say, I don't know, 20 mm. Okay, this is only assumption. I'm not pipeline engineer, I don't know. Okay, this one is a shell, this one is a solid, meaning inside is not hollow, inside is full of material. Okay, so we have one dimension, 1D, we have 2D, we have 3D. This is the type of the mesh or the type of element in DYNA. Okay, if one dimension, we call it beam. If 2 dimension, we call it shell. If 3 dimension, we call it solid. Okay, actually in real life, everything is solid. Even if you have small piece of paper, you see it's very thin, but it's actually solid. It has some thickness. But if you want to model that in DYNA, to make the simulation easier, we just assume it is shell, meaning 2 dimension. Okay, beam elements. Let's say you want to analyze. You see that beam? Okay, it's obvious it's 3 dimension. But if you want to make the analysis simple, you just make one beam, meaning in DYNA you have only one straight line, and you tell the software this one is actually circular section and the diameter is 500 millimeter. Okay, this if you want to use beam. If you want to use shell, you have to tell the software how much is the thickness. Okay, let's say this whiteboard is solid, right? But if I want to model it in DYNA to make it simple, to make the simulation fast, I can just tell the software it is shell element. All right, meaning I just model it like this. Then I tell the software that this shell has a thickness of maybe 5 mm, 10 mm. The last thing, solid. The solid, let's say I want to model a plate using solid, it will be something like this. Okay, so this is what we mean by solid. Right? Solid meaning 3D, shell meaning 2 dimension, and beam means 1 dimension. So you can see now this one is shell, this one is solid. But still the software doesn't know that. So we need to define the section. So we go here, this one, keyword manager. And here, click on this one, keyword manager. Okay, and click on all. Now you have all the commands here. So now you scroll down, you go to section. Okay, under the section, you click on shell. Okay, so now you want to define the what we call it, the thickness of the shell. Okay, again, you click on all, you scroll down until you find section, and under the section you have many things. First click on shell, double click, you have this window. Okay, title, if you want to put title is okay, if you don't want it's also okay, but it's better for you to practice putting the title always so you don't get confused. So this one I say pipeline section, and here let's say I put 10 millimeter. Okay, everything going to be 10, 10, 10, 10, and 10, and then click on accept. Alright, done. Now for the pipeline is done. Now we go shell, pipeline section, put the thickness 10. Alright, ten, 10, 10, all 10. Oh, okay. Good that you asked. This is the shell section, right? This is T1, T2, clockwise, anti-clockwise. Okay. Okay. T1, T2, T3, T4. If I put like this, meaning it's uniform thickness. If let's say I want to make something not uniform, I want to make here is, let's say I want to make it 5 mm. Here, let's say I want to make it 10 millimeter. So if I want to make like this, T1 and T2 will be 5 mm, T3 and T4 will be 10 mm. Okay? Yes? No, the element always will be rectangle. Yeah. Okay. Now this one is done for the shell. Now for the rock. It is solid. So I click on solid. This one very easy. I don't need to change anything. Just put the name solid section and accept. Okay. But if it is very direct for the solid, why I need to do it in the first place? First of all, because the software doesn't know that this one is solid. Secondly, because I want to tell the software what is the type of the element. Okay, what I'm doing right now is called brick element, meaning one element is like this. Okay, we have 1, 2, 3, 4, 5, 6, 7, 8 nodes. Sometimes you have 16 node element. Alright, this one is more accurate. Sometimes you have element like this, 3 dimension, but it's like this, like pyramid. We call it tetrahedron. Okay. So I need to tell the software what is the type of the element. That's why I need to do this step, the one I did just now. Okay. Okay, so far the section is okay. Yeah. For the solid section is very direct. Okay, now we move to the next one. Mat, M-A-T, material. Okay, under the material we have so many options. Okay, so which one to use? But before that, before we choose which one, I need to explain some basics of material science. Okay, we have this curve, we have this x, this y, and we have a curve which is something like this. Okay, almost something like this. I think most of you are familiar with this curve. This one is stress and strain curve. Okay, so what you see here is many options for us to model this curve. If you can see here, 001 is elastic. What does we mean by elastic? If your knowledge is good, you know that the elastic meaning this portion of the curve only, right? Okay, so if you want to model something which is the deformation is very small, we can stick with the elastic material model. So if you want to select 001, meaning you want to define only this portion of the curve, this one we can ignore it. Okay, let's say our simulation is very small, the force is very weak, so we expect the deformation to be very small. So we can only model this, insert the information of this part of the curve. So if you want to do that, what we need? We need this one, the slope. The slope, you know, is Young modulus E. And we need to know this one. This one is sigma here. Alright? And if you want to model the rest of the curve, we have to select more and more complicated material models. So for the time being, we can just stick with the elastic material model 001. Okay, if you click on elastic 001, okay, double click, new ID, let's say steel. Okay, rho is the mass density. Okay, this is the value 7,800. But before you put that, remember that when I first put the dimensions, I used what? This one was, I put millimeter, right? I put this one. I put in millimeter. So the density now, rho, that should be in kilogram per millimeter, not per meter cube. Okay? And for steel, this one is 7.8, 10 minus 6. Alright? So we have to put this value now. So 7.8 E minus 6. E is 200 gigapascal. Alright? Our units here is gigapascal. So you just put 200. You don't need to put 200, 10 power of 6, whatever, no. Here our units already is in gigapascal because I'm using millimeter. So right now we just put 200. So here you try to put 200. Poisson's ratio 0.3. And that's all what you need to do. And now click on accept. Done. Okay. This one we said is for the pipeline. It is made from steel. Alright. This one is just a standard values for the density, for the Young modulus. We have many grades of steel, and depend on which grade you are using, you can put the value here and here accordingly. Okay, done. Now we want to define the material of the rock. Okay, we select number 20, rigid. Material number 20, rigid. What does it mean by rigid? Okay, some people confuse between the word solid and the word rigid. Rigid means it will not deform. The shape, it will be forever like that. So if I define the ball to be rigid, meaning it will not change the shape. Okay. Solid meaning is 3 dimension. The solid sometimes can be deformable, can change the shape, and sometimes cannot change the shape. Okay. if the shape is constant, or we want the shape of the material to be constant, we set it to be rigid. Okay. Right now we have the pipeline, and we assume some rock hits or fall on the pipeline. Okay, so it will bend like this. What is our interest? We want to study the pipeline. We don't want to study how the rock is destroyed, right? That's why in this problem we can set the rock to be rigid. Okay, because in real life the rock will smash the pipeline very strong. The rock, maybe it will break down. But we're not interested in the rock. We want to study the pipeline. That's why in this one we can simplify and say the rock is rigid. Okay. Alright, so now rigid. Double click, new ID. Here we call it rock. Okay. The density I checked yesterday is I have it here. Is 2.6. Alright. Density is 2.6 A minus 6. This one you can put it 200, does not matter. And Poisson's ratio also put 0.3. This one is not very important. This one is the only important one. And accept. And done. Okay. Here the rigid part. I will teach you a small trick. Okay. If this one is rigid, there is a small trick where you can play with the weight of the material. Okay. For example, if you have this shape, okay, and let's say everything now is underwater, and this pipeline is underwater, and the ship is sinking and falling on the pipeline. Okay, so if you model everything, and as I said, we are interested in the pipeline, so we can say this guy is solid. Okay, the actual weight of this one, let's say 500 ton. So if you want to achieve the weight 500 ton, we can play with the density of the material. Okay, understand? Because if we increase the density, the weight of the material will be heavier. Okay, so that's a simple trick for you to know later. It might be useful for you later. Okay, now we accept. Done. Click on model. Everything else will disappear. Now click on part. See, on part you have two things, which is the two bodies, this one and this one. Okay, so this is part number one, is L shell, which is this pipeline. So I can change the title to be pipeline. Okay, what I'm doing right now, I have this guy and I have this guy. I have this, we call it part, and this one we call it section, and we also have the material. So we have three things now: material and section, and we have part. Now we want to link between the part and between the section. Okay, we want to tell the software this solid section is actually for this guy, and we want to tell the software this steel material properties is actually for this one. Okay, so because right now the software doesn't know which one for which one. So here we have the pipeline. The pipeline is this one, right? And it is shell. So section ID, click on this small dot. You have two sections that you define. click on pipeline section. When you click on that, before you done, you can see shell. It tells you the type of the section, and done. Now same thing for material. We have two things, steel and rock. Now just click on steel. You can see is elastic. Alright, and done. Now click on accept. Then again, this is too big. Click on sphere solid. Sphere solid is this, the second one. So you can say is a rock. Now section ID is solid section, and the material ID is the rock material, and click also on accept. Okay, now done. Okay, now we have 3 more steps to do. 3 or 4, or I think even 5. Okay, so right now everything so far so good. Okay, right now the rock is not moving and the pipeline is also not moving. So the next step, the next 2 steps we're going to do, first we're going to fix the pipeline. Okay, the pipelines come in section, right? 1, 2, 3, 4, 5. Okay, each section like 9 or 12 meters. So now because we model only one, we did not model this guy, and we did not model the other one. We only model the one in the middle, right? The blue one. Alright, because the blue one is the one that going to be hit by the rock. You see, it's already bent. Okay, so it's actually fixed in this side and fixed in this side. So the next step, we're going to fix here and we're going to fix here. Okay, to do this we have many ways, many approach to do this one. So the most very direct and easy one, you click here, create entity. You cancel this one here, create entity, and boundary SPC. SPC stands for it means spatial point coordinate. Click on this one. Okay, now you have 3 options: show, create, modify, or delete. Of course you want to create, so click on create. Okay, now you see this small window says select nodes. Now with the help of this small window, we're gonna select our nodes or our points that we're going to fix. So we can say select the nodes by edge. Alright, select by edge, and select on propagate, and also the degree, make it 45. What does this mean? This means if I zoom in, it is something like this, right? I have one edge, one edge, one edge, like this. Now I click on edge, meaning if I click on this edge, this node and this node will be highlighted. Okay? But now I click on propagate and I put the angle 45 degrees. Meaning if I click on this one, the selection will propagate 45 degrees. Okay? So I will show you by examples. So first, I do not put on propagate, and I zoom in, I click on here. You see only this one and this one is highlighted. Alright? Okay, now I deselect. Now I click on propagate. I do the same thing. Now if you can see, everything is highlighted. I'm not sure if you can see. Can you see this one? The notes? Okay, never mind. I will change my background. Background, I make it black. Okay, again. See, now I select by edge. I do not do the propagation option. So only these two is highlighted. So now if I do the propagation option, the whole side is fixed. All right. So we want to fix from both sides, of course. Okay. Click on, hold the control and scroll the mouse to zoom in and out. Then rotate. And now click on the other side. Click on the other side. And you should have something like this. Okay. Now you highlighted the nodes or the elements that you want to fix, but how you want to fix them? You see here you have the options. Okay. The degree of freedom. If you look here, oh sorry, I select by mistake. Click on this one and click on this one. Yeah. Right click. Yeah. All right. You see here, this up here in the x direction. All right. So the ball, the rock is going to hit from the x direction, meaning we don't want the pipeline to move in the x direction, but it is free to move in any other direction. So I can, here I click, make it tick, meaning it is fixed in x, but in y, in z, the other degree of freedom, it is free. Okay. All right. So click on apply. So now everything okay, right? All right. Okay. Now we are done fixing the pipeline. Now our pipeline, section pipeline, is fixed, but we did not tell the rock to fall. We want to assign the velocity of this rock. Yes. Yes. Okay. All right. Good that you. If you are playing around, you zoom in, zoom out, you rotate, then somehow you don't know where did your model go. You click on this one, auto center. Now everything will appear in front of you. Okay. Now we said this rock will fall on this pipeline section, but we need to assign the velocity. So we need to decide what is the velocity of this rock. Okay. For your knowledge, this one we want to say it is free fall, meaning the rock from up the mountain, it just fall like that. There is nobody throwing it down. All right, it is falling because of the gravity. Okay, so this is the rock, this is the mountain, and somehow we have a pipeline here. Okay, and it is falling here. Okay, so now from here to here we have, let's say, the height h. Okay, so we want to know the velocity of this one. How to know? Okay, this one will fall until it's hit, before it hit the pipeline. We want to know the velocity. Okay, all right. This one, when it is up, okay, when something is down and I raise it up, we have something called, I give it some energy. We call it potential energy. Okay, and there is different type of energy. We call it kinetic energy. It's the energy when you move something. Okay, so we have potential energy, we have kinetic energy. This one is what? This one is what? Okay, potential energy is when you lift something. Okay, when something is falling from here, it has some energy. When it is going up, it will fall harder because the energy is higher. Okay, and this one, mgh. Okay, mass multiplied by gravity 9.81 multiplied by height. Alright, this one kinetic energy. If something is going fast, a car or anything, how to find the kinetic energy is half mv squared. Okay, so we use these two equations to find what is the velocity, because our velocity is actually because of the kinetic energy. So if I put this one equal to this one, my velocity will be square root of 2gh. Alright, so for your information, if you want to design a free fall simulation, you want to know the velocity, you just put here 2gh. It does not matter what is the shape, it does not matter what is the weight, you just need to know the height. Okay. Alright, so in this problem, I assume that after all the calculation, I got 20 meters per second. Okay, so here I click on keyword manager, click on all, because you want to define something new. Okay, you scroll down or scroll up to find initial. Okay, initial, then velocity generation. Okay, everyone is here, huh? Okay, now when you have the velocity generation, you have here Vx, Vy, Vz. Alright, so we move our friend here. We see this is the x going positive up, so we want this rock to move down, so our velocity should be minus in x. So I put minus, let's say it's 25 meter per second. Alright, now I just tell the software this is our velocity, but I did not tell it which part is moving. Is it the rock, is it the pipeline, or is it both? So I click on here, S type. You can see here, 1 is set ID, 2 part ID, 3 nodal set ID. What does it mean? Okay, if I have two things, let's say I have two things I want them to move. So I click on put number 1 and I click part set ID. But right now I have only one part. So I click on 2 and here press on this one and you click on the rock. This one. Okay. You have 1, 2, 3, right? Okay. Let's say I have this rock, I have two rocks, two different parts. So I want both of them to move at the same velocity. So I just define what we call it a set. Okay, I define this set contains this part and this part. Then I put it there. And by doing this one, both of the parts will move at the same time. But right now I have only one part, so I choose part ID. Okay, I repeat again. This one. Okay, it says node set ID or part ID. This one, S type. This one, okay. This one actually decide what is this one. Okay, because right now I click on 2, part ID. So if I choose number 2, the one will appear here all only parts. But if I click on 1, then I go back here, I will see only the set of the part will come. Okay, you see here, I click number 2, right? I click here, I have 2 parts. But right now, I did not teach you yet how to make set. So if I say number 1 here, and I click here, it says set part is not available. Choose, no, we choose number 2 part. Yeah, we created 2, but we want only the rock to be moving. If you want both part to be moving, then we choose part set. Okay. Okay, accept. Okay, to answer the question, I will make extra step. This step is not necessary actually. You go here, create entity. You go down here, set. Oh.
Just finish the part. Go where?
Okay, this is actually extra step. Create entity. Go down, set part. Set data, set part. Now you create. Okay, you click this one and you click this one. Now you put the type, the name, whatever you call it. They say set of rock and pipeline. Again, this is extra step. You don't need to do it anyway. And apply. Okay, now you cross cancel this one. You just put any name. Now you go again to keyword. Yeah, you click both of them. Yeah. Now if you go to velocity generation, you see here, now I change from number 2 to number 1. Now I click on this small dot. Now you can see the set that I defined just now. Yeah. Yeah, both of them will move. But a big problem is you might not see the pipelines moving because you already fixed from the side. So maybe it will be a small bending. That's all. Okay. Not very bend. It's just moving a bit. All right. Because this one initial velocity. It's not constant velocity. Initial velocity meaning it will just give the velocity at the beginning, then it will just leave it like that. Alright, so if you have the pipeline, you just give it a velocity down, it will just like vibrate a bit, that's all. It will not move down because you already fixed one side. Yeah. But if you, let's say you free one side, you might see a bit of vibration. Depends on how much is your velocity. Okay, so we go again, move to number 2, part ID, and the rock, you want to move it. Now accept. Done. Okay, 3 more steps. I know you're confused already. 3 more steps. Okay, yeah, 3 more steps. Okay, let's say if we complete everything now, we did not do the next step, something funny gonna happen, which is the rock will move, the pipeline is fixed, yes, but the rock will go through the pipeline because we did not define the interaction between both of them. This is what we call it contact. You go up here, you see contact. Okay, click on contact, double click, you see again you have so many options. Okay, you have like airbag, you have beam to surface, you have general, you have so many things. Depends on what type of the material, of what type of element you use. Okay, but here you can use automatic surface to surface. Okay, this one can be used in almost all the impact problem. So click automatic surface to surface. Now click new ID. Now let's say rock and contact rock to pipeline. Okay. All right. Now when we define the contact, surface to surface, meaning we have 2 things. Okay, we have surface to another surface. One of them we call master. The other one we call slave. Master and slave. Okay, the one that is moving to the one is not moving, we call it master. The other one is moving, we call it slave. Okay, so in our problem now, the rock is moving and the pipeline is not moving. So the pipeline is the master and the rock is the slave. Okay, now both of them, the rock is a part and the pipeline is also a part. They're not set, they're not anything else. So here, before we choose this one and this one, here you see slave type, you have so many types, it is a part. Okay, our slave is a rock and the rock in our problem is a part. So slave, we change slave type, we change it to tree. Master type, the pipeline is also part, change to tree. Now here, click on the dot, slave type ID is pipeline, sorry, the slave is the rock and the master is the pipeline. Click on accept. Okay. Alright. Again, the same thing that I explained before. Let's say we have two pipelines and you have one rock that will hit two of them. So in that case, we can put the master as set and we define a set with all the pipelines. Okay. All right. Yes. Yeah. Slave ID, this master ID. Okay, if you want to go a bit more deep, here you have the friction, static friction, dynamic friction, you have damping, you have viscous friction, you have a lot of things. Okay, two more things, then we are done. Click on all again. Okay, now we want to tell the software when it will finish the simulation. Okay, when time is equal to 0, it will start when time equal to 0. When time is equal to 0, this one will move with the velocity 25. But when it will finish, that's the next step. We go to control, scroll down and until you see termination. Okay, end time. Let's say our end time of this simulation is 50. Okay, then 50, then click on accept, and I think that's all done. Yeah, 50. Accept and done. Okay, now the last step. Database. Okay, now our simulation will start from time equal to 0 until time equal to 50. So you have question?
Yes.
Yes.
Since we have so many steps, how do I check whether my step is correct?
Okay, you complete everything, you save as K file, then you run in the LS DYNA manager. If there is a mistake, the solution cannot run. The
So
soft
I cannot check what I have input previously in yeah, like what I can like just now termination with the details of what I have input.
okay, you have to click. I mean, you can check manually.
One by one.
Yeah.
Not show in one page.
Well, okay. See, I save. Hey, I think I saved this one. Desktop. You can do that, but it is the only way is to open it with file editor. WordPad. Yeah. Keyword .k. Now you can check. You see here, this is the surface to surface. This is the node set. This is the one that we fix. This is the termination time. Okay, This is the material elastic. Okay. All right. Okay, last step. I was saying now the simulation will start from time equal to 0. Oh, another question.
This pop out the question.
Okay, okay, it's okay.
So since the camera is it can open with the notepad, right?
Yeah.
We actually don't need to open here to edit some of the video.
Yeah, you can open from the notepad.
And then can edit it
Yeah.
on the notepad.
Yes. Okay, I will show you example. Here I save, right? Close this one. Right. Okay, this one I close also. This one I open with WordPad. Okay. Yeah, okay, I change to 75. Then I save. Save ready, close. Now I try this one. I'm not sure it'll work or not. Okay, it's working. Now you see control termination, tada, 75. Okay, we're doing like this just now, right? Okay, now the last step is database. Okay, again I was saying our simulation will start from 0 until now 75. During this period, how many outputs we want to see? Okay, so we go to database. Here, database and D3 plot. If we put dt equal to 1, meaning every 1 second we will have 1 frame. Okay, so when time equal to 1 we have 1 picture. When time equal to 2 we have another output. Time equal to 3 we have another output. Okay, so the smaller the value this one, the more smooth your result will be. Okay, so for this one I say I put equal to 5. Okay, I put equal to 5. Accept. Done. Now I save. dt equal to 5, or you can put 1 or you can put 10, but don't put very small number. 1 is fine enough. Okay, now save. If everything is okay, now you open this one, the LS DYNA manager. You click on this arrow going down. Okay, this window will appear. Now you browse. Okay, again you from the LS DYNA manager click this one. Okay, the arrow going down, or you can go here, solver, start LS DYNA analysis. Either you go here or you click on this one. Now this window will appear. You browse the file. What is the K file that you want to use? You want to run? Okay, here test1.k. Alright, so now if I hit run, the LS DYNA will try to solve the simulation file that we did just now. So click on run, and if there is any no problem, it will just run. Okay, wait, here, right? Okay, NCPU, how many processors you want to allocate for this one? Okay, if you have very good PC, you have 8 core processor, you can put 8. All right, and this one, how many of the RAM memory you want to allocate for this one? Usually if you have big K files, you need to manually put big numbers here. But usually this is a very small problem. You don't need to play anything with this. Okay. You click browse. So, sorry? Oh. Sorry? Okay, this one. This one. Okay, model check 10 cycles. All right. When behind the front of this one, the software runs in cycles. All right. If you remember from the lecture yesterday, in FEM we use integration. So how many integration? Okay, so this one meaning every 10 integrations it will check the model, is it okay or not? Yeah, something like that. Okay, you want to see the result. If you want to see the result, you can click on this one. All right, the red one. If you run this, if you click this one, click on OK. All right, click on here again. So now you can see everything. All right. Can you see this one? Click on this. Remember to click on this one. Okay, you see the desktop. If you run the file and everything is okay, you will have this D3 plot file. Okay, this is the result. This one and the rest. Okay, so how to open that one? You can do like this. You open this one first, and then file, is loading. Okay, file, open, and Control B, binary plot, and select D3 plot. Okay, and now open. Now you will see this one. You will click on this one so that you can see everything. Okay, I will use this one, the same version that you're using. Okay, click on this one, zoom out. Okay, now you see the ball will hit, the pipeline will bend. You cannot see this one? Okay, if you're not getting the same thing I'm getting, or if your ball is going through,
Yes, going to.
meaning you did not define the contact.
I didn't accept the contract.
Oh, but why you have to accept?
Wow, it's bouncy.
Okay. So you know your mistakes, right? Okay, click on this one. Click on setting and click displacement scale factor and click on apply. Here, this one, setting, displacement scale factor, and apply. This one, if the deformation is very small and you cannot see it, you can, let's say, put it 2, apply. You see the deformation is more, but the actual deformation is 1. Okay, I have to do this one. find a way. Okay, if you are getting this one, now you can see some of the results. Okay, I think for your version you have to wait. You just follow me first here, because I need to find the solution why I cannot view in your version. Here I have, this one is 4.3.13. This is a new one. Now you can see almost the same problem. The things that you can see from here. You go to post-processing. Here you have all the results. Here in the fringe component you can see many things. Here you can see all the type of the stresses. Okay. Here is the nodal displacement. Okay. You click on one node and you see the displacement or the velocity or whatever. So let's say we click on X velocity. You can see this is the velocity of the plot of the velocity. If we go to stress again, you have strain, you have pressure, and you have the equivalent von Mises stress. So you have a lot of things that you want to see. Okay, right now, as I said, we want to study the pipeline. We don't want to study the rock. The rock is actually not in our interest. So I hit on F2 and click only on the pipeline. So the rock will disappear. Now I can see everything more clearly. Okay, now I'll try to go to the next one. This one you can follow me. Okay, go to history. Okay, again, here I have few options. Let's say I click on parts. I see total part energy and click on the pipeline. And now you try to plot. Now this is the plot of the energy absorbed by the pipeline when the rock hit this pipeline section. Okay. Again, I show the rock. Now I try to go to clear. I click on clear. Go to nodal. Or click on the pipeline only. Okay, I close this one. Okay, output, post-processing, history. I click on nodal, then I try to click here, then I click X displacement, then I plot. Now here I can find the displacement or how deep the deformation in the pipeline. You can see the distance, how much this point has gone down. From up, how much it goes down. Okay, this one. Okay, let me continue here better. This one is your solution. Okay, so I click on F2. I hide the rock. I only show the pipeline. Okay, now I want to know how deep is this dent. So I go to post-processing. I go to post-processing. I go to history. then I click on node, then I say X displacement, because this is the X direction. So I click on this one and click on plots, and you see this is the deformation. So the maximum dent is like 600 millimeter. Okay. Okay, so far so good. Everyone can follow, huh? Okay. If you have any questions, please ask. No. Okay. So, since we have everything okay, we just try to play with this model and see if we change few things, what will happen. This one I can close it. This one, so close it. This one I close it. Okay, I want to, where is my K file? This one. I just drag here. Okay, so we have, this is our model. You will see it like this. Okay, now click on here, create entity, set data, set node, and click on this one. Okay, maybe it's not very obvious here. I click here, this one, and the background I make it black. Okay, so again I go to create entity, entity creation, set data, and set node, and click this one. Okay, you see when I click this one, you have this node, this side, and also this side. Okay, this actually the nodes that we fixed before. So right now I want to make one side free and see what is the effect of our simulation. Okay, so I click on modify, click on this one, on our node, a node set that we want to change. So now you see we have these two sides are highlighted. So what I do now, I want to unselect this one. I want to remove this one, this side. So I click by area. Okay, so right now whatever inside this area will be selected. So you see I click, normal click, I make area. Now everything will be selected. No, I want the opposite. I want this side to be unselected. So I click on the right mouse button and make this area. Now everything will disappear. And if you do that, click on apply. So now you see only one side is fixed. You see this side, nothing is there, and this side, you see it is fixed. Okay, all right, we only changed that one. Now we Control S, we save. Now we run the simulation again and see what happens. Okay, what, very fast, huh? Creation. Okay, here, go to this one, model and part, and go here, create entity. Create entity or entity creation, the same thing. Yeah. Now go to set node. You modify the node that you already have, and you just unselect one side. Okay. All right. I will do it again. Wait. You can see like this. Set node, you can see. You don't have this one. Okay. All right. Now you have this one. You click here. You click modify. You click on this one. You see this one is yellow. This one is yellow, meaning you are selecting both sides. All right. Now we want to remove one side. So I click on area, and with the right click mouse, I make area like this. So now whatever inside this area will be removed from the selection. Now click on apply. After you do that, click on apply. Now you see only one side is there. The other side already disappeared. Okay. Okay. Now we open the LS DYNA Manager again. Here there is a small shortcut. You see this one, the one in the middle. Okay. This one will will run the same K file that you did before. Okay. So the K file that our first simulation is the same thing, the same name, the same location. We did not change anything. I mean, we just modify and we save it the same name and the same location. So I can click on this one only. So if I click on this one, it will resolve again. Then after everything is solved, I can click on here to see what will happen. Click on this one. Now remember, in our case now, one side is fixed and one side is not. Now you can see it is bending. You see it's bending from one side. Here you have F and here you have S. S is slow and F is very fast. Okay. All right. Okay, now I will open two files that I did before and I show you some steps. Okay, this one is one file and this one is another file. Okay, these files, what I'm going to show you now is for your future reference. Okay, you see here, this one is one file, this one is another file. The rock is almost the same, but the difference is in what? In the pipeline. Here you have the elements a bit bigger, here the elements very small. Okay, And this is the final deformation here, and this one also the final deformation. So I unclick on this one and unclick on this one. I will try to show you, let's say this one, this is the stress, and here also show you the same exact thing. Okay, so this one is the one with smaller elements, and this one is with bigger elements. The same problem, everything exactly the same, only the size of the element is different. So you can see here we have like orange area, here we don't have that orange area. Okay, so why we have this one? Because here the element is smaller, meaning our result is more accurate. Okay, so if you have smaller element size, your result will be more accurate. But if you are very small, your simulation time will be very long, and maybe it is not necessary. Okay, that's why sometimes we have something called mesh sensitivity analysis. Okay, what does this mean? Meaning we run the same thing, the same problem, everything exactly the same, only the size of the mesh we change. And we see how much that will change our result. Okay, sometimes we can make very fine mesh, but the final result is not, it doesn't change that much. So we don't need to go into very fine mesh. Okay, so that's sometimes we need to do this mesh sensitivity analysis. Okay, but for basic or first simulation, we can use big size element, is no problem. Okay, so any question? Just try to do, and if you have any problem, just ask. What do you mean one by one?
Right. If you found at least like everything, right? What I did.
Yeah.
So is it possible that it not can open the result file to see the result in one shot, not like one by one on the
Oh, okay. Alright, the thing is because in the result we have so many things. Okay? So if that option is available in the variable file, that's why you still need the pre-post in order to show the result. And sometimes the result are graphical. You have, you see like this. If it is like this, how can you explain it in a file, in a report or in what you call it, the Word file? It's difficult, right? When you have a plot like this. Yes. Yeah. Yes. Because most of the time only need one or two results. You don't need everything. Okay, in this one, you see the plot, the graph. Okay, from there you can import, you can take the yes, yeah. We don't have that feature here, like ANSYS. Okay. Since you were talking about ANSYS, few differences between ANSYS and DYNA. ANSYS mostly used for, we call it implicit problems. Okay, implicit problems meaning the force or the load is very small. Okay, if you have this table and have this board, let's say it's very heavy board, and I put it here. Then I want to know what is the effect of this heavy board on this table. Okay, then we use sometimes software like ANSYS because it is implicit solver, meaning implicit meaning we studied in structural mechanics or mechanics of material, whatever you call it, sigma equal to P over A. Okay, force over area equal to stress. Okay, but do we have any time function here? No, right? Because it's suddenly this table is like that, then suddenly there is a load on it. Okay, thus we call it implicit analysis. All right. But in LS DYNA, it's more explicit analysis, meaning we have time in consideration. All right. Even if I want to apply a load, I need to tell the software what is the rate of this load, how does it go up and down with time. It's not constant. All right. Okay. All right. So do you have any question? Okay, you don't have internet here. You guys don't have internet. Okay, wait. I need to stop this guy because it's recording for nothing.